In this video, we're going to talk about average cost and how it relates to marginal cost. And this is useful when you have formulas for cost, and then you can get formulas for average cost and marginal cost. But it's especially useful when we have graphs like we just did in the previous video. And so what we're going to do is we notice that, oh, that marker doesn't work at all. That's what we're going to notice. Average cost is total cost divided by how many we're producing, Q, our quantity. And if we want to look at, for instance, a minimum of average cost, we want to minimize average cost, we would want to find the derivative. And using the quotient rule on this formula, we would get derivative of top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Now I'm going to rewrite this a little bit, and I'm going to rewrite it as C prime of Q times Q over Q squared. What I'm doing is I'm separating it into two fractions, minus C of Q over Q squared. And in this case, for this term, the Q's on top cancels with one of the Q's on the bottom. So I will rewrite this one more time. To clean it up. And now I'm going to do another algebra step where I'm going to take out a 1 over Q from both of those terms. And when we do that, we're left with C prime minus C of Q over Q. So what we just did is we used the quotient rule and then some algebra to rewrite the derivative of average cost is marginal cost minus average cost. And because of this nice, all of these algebra steps, we have this nice formula which gives us some nice ideas. One is that we have a critical point of average cost. Okay. Normally we'd set this equal to 0. Well, when we do the algebra on this, that would be when these guys are the same thing. When marginal cost equals average cost. So I'll just write it in the words. Right, so we have a critical point when marginal cost equals average cost. Well, when marginal cost is bigger than average cost, that means this is positive. Which we talked about when the derivative is positive. That means average is increasing. Average cost is increasing. When A prime is positive, A is increasing. So our average cost is increasing. So what this does is it gives us the idea that we may want to decrease production to reduce our average cost. Right, so again, we may have been told these facts in another class, or we might be told in a future economics class, right? When marginal cost is bigger than average cost, this is what we want to do. But it's because of this formula. And likewise, when marginal cost is less than average cost, then what does that tell you? That tells us A prime is negative. A prime is negative. That tells us A is decreasing. So we're on the part of the curve where average cost is decreasing. So we want to increase. So we may want to increase production. When marginal cost is less than average cost. And again, when we have formulas, we could figure that out when A prime is negative. But on graphs, if we have a cost curve and we're looking at a production level like this, the slope of this line is our average cost, and the slope of the tangent line there is our marginal cost. So now, without any formulas, we know whether or not we should increase or decrease production. Average cost is bigger than marginal cost because the slope of this line is bigger than that line. So we may want to increase production to decrease average cost.